Radhe Radhe everyone. So I guess I'm visible and audible, right? There is a little bit of lag from my end. I can see that there are a lot of drop frames, but it's not because of the internet quality. It's because of the internet. I mean, it's because of the RAM thing. Okay, it will get fixed. I think there is no problem with my audio. I guess, right? Stop. Okay. Okay, so I think now everything is proper, and we can start with today's solutions. First of all, I'll ask you guys how many questions did you guys solve? Okay, and I know my face won't be that clear actually because I'm using the opposite side of the sun. So yeah, how many questions did you guys do by the way? And I'm audible, right? How many questions did you guys do? Okay, I'm audible. Minimum first question, okay? Minimum cost to reach every position. You're given an integer array cost. I'll just put it a little bit over here of size n. You're currently at position n at the end of the line in a line of n. Okay, I'll just put it up a little bit front of me so that you guys can see me. Okay. You wish to move forward. Okay, you are currently at position n at the end of the line in a line of n plus one people, number from 0 to n. And you wish to move forward in the line, but each person in front of you charges a specific amount of swap places. Cost to swap the person I is given by cost of I. Okay. You're allowed to swap places with people as follows. If they are in front of you, you must pay them cost I, and if they are behind you, you can swap for free. Okay, so it's basically like think it like this. There are some people. I wait, wait. Even Excalibur is lagging. Oops. Just a minute. I'll just refresh it. Okay. Ping is perfect, so my audio won't be getting hampered. Just there's a fact that FPS is a little bit low because of the CPU usage, which is high. I don't know why. The FPS is getting quite low. The ping is okay, right? The ping is okay. Okay. I don't know how bad the ping is getting. Just need to check it. Ping is perfect. So my audio won't be getting hampered. Just there's a fact that FPS is a little bit low because of the CPU. Just I why the FPS is getting quite low. The ping is okay, right? The ping. Even the ping is not okay now. It is still better, I guess. 28 frames out of 30. Yeah, 20 frames out of 30. Okay. See, it tells us that whenever you're seeing this cost, right? So there's a person who is standing just over here. Okay. Now that the person is standing just over here, what he can do is Code of Excalibur. Reload this. Okay, I think I now I get it, like why it is having like this. Why the ping is so high. Let me just fix it, okay, quickly. It's because like some windows are still loading. This is okay, this is loaded, this is loaded, this is loaded, this is loaded, this is going to be loaded, and this will be loaded. So what you guys can do is you guys can wait for just 2 to 3 seconds, and once these windows are loaded, I can start. Okay, so that like it's going to give us a better thing. Okay, 13.13 FPS is not that good. This usually happens after a Leetcode contest. I've seen this because there are a lot of people who are doing it, and it happens like that. It tells me encoding overloaded. So I think it is also a issue from Excalibur also. I forgot how to fix the encoding thing. I think settings is the thing. Even Excalibur is not. I mean, this is also not getting. OBS is not working. Well, I think now it is perfect, right? Okay. Mm, stream. Okay, I can't do it. I can't do it while streaming. Or I can. Can I? Encoder is very fast, faster. We can go for super fast, right? I think we can go for super fast. Okay. Yes. Now I think it will be kind of fixed, right? And you guys won't be able to see the live stream because of that reason. Okay, I mean the chats, but you don't need to worry because I can see it. Okay, or rather I'll do one thing. I'll put it out over here. Okay, for you. I don't know how to. I forgot how to do it. Bear with me for a minute. Okay. Okay, so this came up now. Okay, great. messed up a lot of settings. Okay. I, I'm not expecting much viewers today. Okay, let's. Everything is okay. No, I had OBS from. Okay. Now you can see. Great, great, great. Close. OBS is perfect. 30 FPS, 30 FPS, encoding overloaded. Okay, it's not an issue. It's perfect. I think Excalibur should also work perfectly. I'm sorry for the interruption. Okay. It should work perfectly. There's a little bit of lag. I think it will be better for me to use Paint. Okay, so whatever we were discussing, okay. So it basically you have to think of it like you are present at this position. Okay, I'll do one thing. I'll just start from the beginning. Okay, so it's better. So question one: minimum cost to reach every position. You're given an integer array cost of size n. You're currently at position n at the end of the line in a line of n plus one people. You wish to move forward in the line, but each person in front of you charges a specific amount to swap places. The cost to swap with person I is given by cost of I. Okay. If the now you're allowed to swap in various conditions. Like if they're in front of you, you must pay them cost I, and if they're behind you, they can swap with you for free. Okay. Return an array answer of size, where answer of I is the minimum total cost to reach each position I in the line. Okay. So you're, let's say you're present over here. Okay. Uh, okay. So there is a person over here. Let's say. Okay. I think this is okay. There is a person over here. Okay. Now let's say you are present over here. Ignore my drawing. So there are a few people over here also. Now you have to find out what is the cost that you have to incur to get at any position. Let's say we have to get at this position. Okay. Now see, if I want to get at that position, so there are various steps to do it. Okay. I can directly go to that position, or I can go to a position ahead of it and then come back, right? Or I can go like this also. Let's say if I have to reach this position, okay. So I can directly reach this position. I can go to this position, then come back, go this position, then come back, or go to this position, then this position, then come back. So there are various opportunities. Okay. But remember one thing, that if we are coming back, so that doesn't need any cost, right? So now since that getting back doesn't need any cost, so it's better that if you can get to that position, it's good. But if you have to go to a position ahead of that, then also that's good. Okay, we can go with it. So basically, which is more beneficial for you? So we have to check that for all the positions from that. ये नहीं दिख रहा भाई, क्या लिख रहा हूँ? ओपी बाकी सब ओपी. Sorry, I didn't get it. So you have to get to that position, okay, right? So let's say if I'm considering from this to this, so I can get to any position that is from there, okay, that is coming from here to here, and whatever the cost that I have to incur to swap to any of the positions is going to be cost to reach this position. Okay, to reach this specific position, I'll use a different size actually. Yeah, to reach this position. Now that I know that, so what is the best approach? The best approach will be to find whichever is the minimum, right? Whichever is the minimum. So from this, whichever is the minimum, go for it. If I want to go till this position, if I want to go till this position, so I have to find out whatever is the minimum from here to here. So it is basically nothing but prefix of min. Okay, prefix of min. So if you look at the code that I've done, you'll get to understand what I've done. M is equal to 101, n is equal to cost dot size. And then what I'm doing is, okay, then what I'm doing is m is equal to minimum of m comma cost of I. Okay, so because I am doing it like what is the minimum cost till that position. Okay, and cost of I is equal to m and return. Topi is equal to hat. Okay, where do you see the hat? Is there any hat? I don't find it. I don't find it. Okay, so I hope this problem is clear. So let's move on to the next problem. Okay, next problem tells us it is also a very simple thing. Longest palindrome after substring concatenation. You're given two strings s and t. You can create a new string by selecting a substring of s, possibly empty. Okay, and a substring of t, possibly empty. Then concatenating them in order, you have to find the length of the longest palindrome that can form this way. What does it mean? It means nothing but the fact that I'll use a more darker color now. Let's say if I'm having an array like this. Okay, I think paint is better than Excalibur. It is giving me. I mean, I think it is getting my handwriting is getting better in this. So you're having an array basically, nothing else, and in that, like it's an array of strings obviously, and you're also having another array of not array of strings, it's array of character, that is string. So you're having also another string. Okay, now what you can do is you can choose any. Oh, I think I changed color too. So you can choose any substring from here and any substring from here and concatenate them in order. That is, yeah, I know that's teaching. So it means that 1, 2, 3, 4, 5 in this specific order. If I put them together, so it should be the palindrome. Okay, and I have to find which is the longest palindrome possible. This is very simple. I don't think I need to make you go through like what is the explanation for it. So first of all, I'm having a is palindrome function, okay, which is going to take the string s and n is equal to s dot length. So you just have to check for the palindrome, you know that. And then in longest palindrome, what we are going to do is we know that answer is equal to 1 because if we are taking only one specific alphabet, it is also palindrome, right? So for int I is equal to 0 to I less than n, I is, j is equal to I to j less than n, k is equal to 0 to k less than m, and l is equal to k to l less than m. So what does it mean? M is basically the length of t and n is basically the length of s. So I am going to consider all the substrings of s, all the substrings of t, and I'm going to add them, that is concatenate them, and then consider it. And for all the, like we are also going to check for a because it may happen it was given that possibly empty, right? It was given always possibly empty. So we have to check for possibly empty also. I also do sorry this is a bit off topic, but I only give photos. So do you think it's worth giving Leetcode contest? It depends on like what you want. Like I give Leetcode contest because they are a little bit less on time. So 1 hour 30 minutes is okay. I feel too much stressed for 2 hours contest of code forces. But yeah, That is CP and I like it, so yeah, I'll also give that. It depends, okay, it depends. Okay, so this is how A, B and A plus B we are going to calculate, and then we can just return the answer, whichever is maximum. Okay, I hope this is clear. Well, I won't be explaining that much because this is the same thing but with a greater constraint. That is, earlier I had the opportunity to do that, but over here the length of that is 1000. So I can take at least big O n squared. Okay, right? This is somewhat what I have done. I'll show you. Oh, I can't see. Yeah, I can. I'll show you the submissions. Okay, my submissions. Why can't I see my submissions? Fuck it. So see, what I'm not sure whether he has explained it or not. I don't think he has explained it. Okay, so first of all, let me explain you what he is telling us. Okay, now that you know that this has to be a palindrome, right? This has to be a palindrome. First of all, let me see whether he has done that or not. What I am thinking of. It is very much similar to that. Left of S. So first try to understand what he has coded out. Okay, and from there we are going to understand what the logic is. So he has the longest palindrome. This is what I have to find. Okay, so he has one dp of m into n. He has another dpt, okay, of n into n. I don't know what the heck is that. For now, I don't know. Okay, so let's try to understand. M and n, okay, we are okay with it. Length was so. How can we conclude that? Yeah, so just calculate it n squared 100 100. I mean 1000 1000. So there are 6 zeros, which means that it is n squared. Now, if you go for n squared log n, so it will be log n will be uh, log of 1000, right? Log of 1000 is 2 to the 4, 4 to the 8, 8 to 16, 16 to 32, 32 to 60. Log of 1000 is nothing but 10. Okay. Now that means that if you go for 1, 2, 3, 4, 5, 6, 7, 7 zeros. Okay. So it's basically you could have also gone for n squared log n. That will also work. But yeah, n squared is fine because I don't feel that there is any need of log n. Okay. So that's it. That's what I mean. So you have to always keep the value 10 to the power whatever it is well within 7. Okay, it has to be lesser than 7. Always try to do that. If you can't, try to keep it lesser than 8 and check it. But sometimes even lesser than 8 gives you a TLE. Okay, so that's how you have to know about it. So just remember 10 to the 7 and 8. Okay, and if possible, try to keep it 10 to the 6. It is the best thing to do. Okay, so what he's doing is from m minus 1 till 0 is moving, and then he's moving from I to m. Okay, he has not given like I get it, the solution is okay, but he hasn't explained it. I want someone who has explained it. Simple Java solution. Let's see. Because Java codes are more explainable by itself, even if the explanation is not there. Okay. Oh, not explained it. Hmm. Well, I'll just tell you what my logic is. Okay. Now, since you know that this is there, okay. What has it done by the way? X plus middle, where middle lies entirely in one of them. This is what I have done actually. I can't show you my solution. So I'll just explain you what he is trying to do. Okay. He is telling us that we are going to find a palindrome in any one of them. Okay. Let's say there is a palindrome over here. I'll denote it with color. Mm, I think yellow is a good color, but no, it's too light. Which color should I use? Blue will be good. So let's say this is a palindrome in itself. Okay, which means that we can consider that. Okay, we are going to consider that. And apart from that, now I will use a black color. Apart from that, I can take some elements from the beginning and some elements from here. Not from the beginning, okay. Some elements before it. Okay, I messed it up. So I can take some elements before it, okay, and the exact same elements I can take from here, which is matching it, right, in a reverse order. So basically, let's think it like this: that there is two elements over here, okay, and there is two elements over here. Now, if this is palindromic, yeah. So if this is palindromic, okay, and these two elements are over here, that is, let's say this is A, is a different color. Let's say this is A, this is B, and over here it is B, and this is A, which means that this is palindromic. And to a palindromic string, if you're adding two alphabets that are same to its extremums, that is, I'm over here I'm adding B, and over here I'm adding B, so it is also palindrome. And before this B, now this is a palindrome, right? And before this B, I'm adding a, and over here I'm adding a A. So now this is also palindrome, which means that this is a palindrome in total. So this is what he means by middle. Okay, this thing in blue, this is what he means by middle. Now this middle can exist over here, or it can exist over here also, right? We never know where it is going to exist. So any one place it can exist, the middle. Okay, and then from this and this, you can find out what is going to be the longest thing. So x plus reverse of x. Now, what do I mean by x and reverse of x? See, I'm not sure whether he has reversed anything or not, but he should have reversed anything or not. And the exact variable that he's using, dps and dpt, that is exactly what I have used. Okay, I'll show you my submission. I'm not sure why I can't see it, but yeah. So see, now what happens? He's storing the boolean dp of s. What is it? I don't know. Okay, but now I'll try to understand what is it. So he's traversing from m minus 1 till j, right? And he's checking that if both of them are equal, great, and a j minus I is lesser than 2, that is, there is a distance of 1 between them, maximum distance of 1 between them. Okay, either both of them are same, at the same distance, I mean same position, or they're 1 apart from each other. Okay, or or dps of I plus 1 j minus 1. So this is what is this? This is going to basically store the palindromes. Okay, this m into m means dp of s of I comma j. Okay, dp, sorry, dp s I comma j is basically nothing but to check whether the substring of I to j is a palindrome or not. Okay, this is exactly what I've done. I told you that if it is a palindrome and I am putting the same element on both sides of it, okay, same element on both sides of it, so that is also palindrome, right? So that is also palindrome. And obviously, like j minus I less than 2 is the condition that it is like I plus 1 and j minus 1 are same, or it is before each other, so that is equal to 0. Okay, that is, it is going to start the condition for palindrome. So this is what we are going to get for the palindrome. Okay, clear? Now left of s of I is equal to maximum of left of s of I comma j minus I plus 1. What does this mean? Any idea? Left of s of I is basically nothing but he is going to store the largest palindrome on the left of s. I mean left of I. Okay, he is going to store the largest palindrome on the left of I. The length of the largest palindrome on the left of I. Okay, and he can get the answer as whichever is the maximum of it. Okay, because you know one thing, that if I get the largest palindrome in this, in S, and I can get the largest palindrome in T, so that is obviously going to contribute, right? I just explained you this thing. I was just explaining that in the previous problem, that I was also checking for A plus B. I was also checking for A and B. So this A and B checking is this. Okay. Now see. Now he is doing DPT. He is doing the same thing for T. He has done it for S. Now he is going to do it for T. But in T, he is not doing it for left of S. He is doing it for right of T. Why is it so? Any idea? Because over here, just look at the pattern. Okay. Which color to use? Green, blue. Okay. So over here, what was happening was that this thing was towards the left of this, but over here this thing is towards the right of. I messed it up. This thing was towards the right of this, and this thing is towards the left of it, right? So over here we are going to consider for the left of S, and over here we are going to consider for the right of S, right of T. Okay, and then what he's going to do is he's going to do the same thing. No much difference. The same thing for DPS and DPT. Now that he's done, so j minus I plus 1 is basically the length of it. Okay, you know that if something is starting from I and ending at j, so the length of it is j minus I plus 1. So that's what he's doing. You get the answer. Well, well and good enough, right? Now comes the main DP. You're done with DP of S, you're done with DP of T. You have got what is the palindrome towards the right of this, what is the palindrome towards the left of this. Okay, great. And one more thing here. One more thing I forgot to mention. See over here, just to make it right, not over here. Okay. Sorry. My mistake. Nothing else. Okay. So now that you know about it, okay. So I was actually telling you this, okay. So left of S of I, and he is using right of T of J, because right means he has to take the rightmost element, that is J, and left means he has to take the leftmost element, that is I. So that is what I was looking for. Okay. Now in the DP, I'm going to go for M into N. Okay. I'm done with M squared. I'm done with N squared. I know what is a palindrome and what is the length of the palindrome from that position. I know what is the palindrome and what is the length of the palindrome before that position. From that position, but before it, and from that position, but after it. Okay. Now what I can do is, this is where he is using the DP. He's just checking that for one specific position and another specific position, if I'm going same by same, okay, that is, if from here, now I'll use which color to use. I'm done with all the colors, I guess. I'll use brown box, I guess. So in this, sorry. So in this portion, okay, he has to traverse like this, right? And in this portion, he has to traverse like this, which means that dp of this comma this, what will it be? It will be a, first of all, it will be a true, and second of all, it will be a 1, right? Now, if he goes to this position, and if he goes to this position, what is the DP? It is a 2, because he can consider this, I mean, he can consider this and this, both of it, right? So that's the reason it will be 2. So that is what he is going to do, m and n. So from I is equal to 0 to I less than m, and j is equal to n minus 1 to j is greater than equal to 0. Why so? Because this, so I was checking from here to here and here to here, but what he is doing is he is checking the opposite way. That is doing checking from here to here and here to here, which is also the same, because AB, AB, same thing, BA, BA, same thing. Okay, so you don't need to worry about that. Now that he is doing the checking, he finds that if S of I is equal to T of j, then dp of I of j is equal to 1. That is what I was telling you, that if it is present, it is 1. Okay. If I is greater than 0 and j is lesser than n minus 1, which means that I minus 1 is present and j plus 1 is present. Okay. So that this is going to contribute to 1, which also means, okay, this is where the thing comes. So if this is 1, okay, let's say this is 1, right? This is 1. I know that this and this is 1. Okay. And I know that this and this, it is also 1, right? But since the fact that this is 1, so I can add to this the element just before this and the element just after this, right? Which makes it 2. Okay. Is it clear how he's doing the DP thing? I hope this is clear. Okay. And if DP of I of j, that means that we have to modify the answer, right? That is, I don't know what the heck is extra. Okay, extra is basically the palindrome. Okay, extra is basically the palindrome, which means that I have to consider the palindrome starting from the position just after this, right? Or the palindrome starting from a position just before this. Okay, so either take the palindrome of S just after it or just before it. Okay, and extra is basically that. Okay, that is the size of the palindrome. I think it will be better if you consider the extra as the size of the palindrome. And now that you get it, so answer is equal to maximum of answer, comma 2 into dp of I, comma, I of j plus extra. Why 2 into dp of I of j? Because the length of this, now I'll use black. Because the length of this, or rather I'll use green. I think it is. So the length of this and the length of this, I have to add them also, right? But I know that if both of them are same, reverse in a reverse order, so both of them are having the same length, right? So this 2 that I got, I have to multiply it with 2, so that I am considering AB and BA. Total how many elements? 4. That is 2 into 2, right? And in mid, how many elements are there? There are 2 elements. So 4 plus 2, that is 6. Now if you go for it, it is 1, 2, 3, 4, 5, 6. Okay, that is what we are doing. Is it clear? This is clear, okay? So minimum operations to make elements within K. Holy Christ. 558 accepted? I felt that this was hard. Okay, so I think that was easy. I messed it up. The previous one was easy. You're given an integer array nums and two integers x, x and k. You can perform the following operation any number of times. Okay, including 0. Increase or decrease any element of num by 1. Return the minimum number of operations needed to have at least k non-overlapping arrays of size exactly x in nums, where all elements within each subarray are equal. Okay, so you have to make all the elements within each subarray equal. Okay. Okay, so this was easy. It messed up with my head, man. I'll tell you what this question tells us. Okay. Or rather, let's do one thing. Let's put it black only. Huh? It looks cool. I'll use a white color to explain it. Okay. See, it is telling us that you're given an array. Okay. Now, in that array, what happens? So, in that array, you can divide it into how many things? You can divide it into k non-overlapping. Okay. See, over here it is given at least k. So, it means that you can make it more than k, but it is obviously good that you just go with k. Okay. You don't have to go for more than k because that is going to make your complexity more complex. So, you don't have to do that. Okay. So you have to make it divide into exactly k non-overlapping subarrays of size exactly x in nums. Okay. So what you can do is let's say if x is equal to 3 and k is equal to 2. So you can choose this subarray and then you can choose this subarray. So both of them are non-overlapping. What do you mean by overlapping? It means that if we were choosing this subarray and then if we were choosing this subarray, so both are having size of 3, but these two blocks are overlapping. Okay, so we can't choose them. Okay, clear? So one of the approach, first of all, let me tell you that the approach that comes to your mind, that should come to your mind at the beginning. Okay, it should be like, let's do one thing. Let's make all the elements equal. Okay, and you know how to make it. Okay, you can have the median out of it for every specific what to say subarray. You can have the median out of it. Okay, so let's say if I want to make all of these three elements equal, so I can find out like how many operations do I need to perform to make them equal. Okay, how can I do it? By finding the median out of it and make all the elements as the median. Okay, clear? I can do it for this one. I can do it for this one. I can do it for this one. I can go on doing it. Okay, right? But the fact is that even if you're doing it, the fact is that even if you're doing it, you have to take one thing into consideration that whenever you're doing it, like why are we considering the overlapping things, right? We are considering the overlapping things. See, initially we are going to consider the overlapping things. Initially, we will be considering, okay, I'll use green, okay, to show you. Initially, we are going to consider the overlappings, right? This is it, right? Very complex circles, don't need to worry much about it, okay? So let's say I can consider this, sorry, I can consider this, and over here, I can store its value, right? I can consider this, and over here I can store its value. Similarly, I am considering all of them, and over there I am storing these values. Right? Now it means that I can take. Can you give your code force and Leetcode? It is. It goes by this. Okay. It goes by either Griffin codes or even I don't remember what it goes by. I think Leetcode goes by this, and code forces goes by this. Okay. So now that you have got it, which means that if you are using, okay, if you're using this, what you can't use this. Okay, the next thing that you have to use is this. Okay, or this, or this, right? If you're using this, the next thing you have to use is this, or this, or this. Okay, so I hope this is getting clearer that what we are trying to do over here, right? So it is basically like we are going to get the by using the median, we can get the values of the red ones, and from there we can get the values of the yellow ones, and we have to take only k of them. Okay, clear? How to get the k of them? You can use a DP. Simple. In this, there is one operation. Over here you can store at one operation. Over here you can store for one operation. Over here you can store for one and two operations. Over here you can store for one and two operations. One and two operations. 1 to 3 operations, 1 to 3 operations. Okay, what do I mean by that? Let's go to the code. For a sub array of size x, it is always optimal to make all the elements to the median elements of the sub array. That is what I was telling you. Okay, I have to make it median. We can maintain two multi-sets to find the median of sub array quickly. So I don't know about this, but yeah, multi-sets. Okay, I get it. Contain all elements lesser than equal to median. We also maintain the sum of this multi-set for quicker calculation. Contains all the elements greater than. Okay. Uh, Now we can use DP to solve this, maintaining the states. Number of partition, this. Okay. So let's directly go to the code. Okay. What he's doing. See, why he's doing it is DP of 16 and 1000 this, because it was given in the question that k is lesser than equal to 15. So you don't need to have a partition of more than 15, right? So you can have a partition of DP for 16. Okay. That is, for 15 partition, what is the optimal answer? For 14 partition, what is the optimal answer? Because for 15 partition, whatever is the optimal answer, it is dependent on the for 14th partition, right? Because you're making a partition after the 14th one, right? And for every partition, there may be a lot of answers, which is 1, 2, 3, 4, 5, 10 to the power 5 plus 1. Why so? Again, let's just see. This is so because it is given that this constant is 10 to the power 5. Okay, so the length is 10 to the power 5. So obviously you won't be having more than 10 to the power 5 in one specific part. Okay, so that is the reason why we are using DP of this. What is MBS? It is used for median. Okay, I hope so. It is used for median. So first of all, let us see what he is doing. Okay, he's trying to calculate the minimum operation for vector int a x key. Okay, k is equal to k and x is equal to x. I don't know why he does that. Maybe some reason, but okay, let's leave it. Okay, maybe because of that shallow copy, deep copy thing. Okay. No, I didn't attempt the add coder yesterday. I was doing the Leetcode, and before that, I needed some rest. Okay. Nice. He is having a multi-set F and multi-set S. Okay. So he's using two multi-sets. Long S1, long S2. I don't know till now what he's trying to do. Okay. Now I'm going to figure out what he's trying to do. For int I is equal to 0, I less than n, I plus plus. If I is greater than equal to x, that means from here I have to consider the medians. Okay. Now I'll just go back to the diagram. See, from where did we consider the yellow things? From the third position, right? Before that, I can't have anything, right? So that's what he's trying to tell us. So from here, it is going to be considered. Now, first of all, let us understand what is there if this is not getting satisfied. That is, where in the initial stages. Okay, that is if int f dot size. What is f? F is actually nothing, right? It is actually nothing. So if it is lesser than equal to s dot size, what is s? S is also nothing. Okay, so in that case, I have to insert a of I into it and sum of a of I, right? Else, whatever it is, okay. I don't have to worry much about it because still, now what color? I'll use a pink color, okay? Because okay, it's the orange color. So from this and this position, we are simply adding the elements. The moment we are at this position, then also we are just adding the elements, okay? But here's a twist over here, okay? What is the twist? The twist is that f is going to have the multi-set getting inserted, okay? It's having while n1. These are the few conditions why sometimes I feel like I should shift on to Python, okay? But I don't think this is a much big of an issue. I think he has just made it at an overall step. I don't think he needed this. Today's Leetcode C was 240 rated. But I think I messed it up, man. I was very close to it. I should have gone for it. I should have done it. It was so close. I'll show you my submission, okay? And you'll look at the explanation of the code that I explained. It was so simple. So you know what, like, what is happening these days? It's like I'm thinking of something, but I'm not being able to code it up because of the time constraint. Okay. So yeah, it's about practice. I have to practice more so that I can get into it. Okay. So that's it. It is not completely based on Z algorithm. Z algorithm, like you mean that KMP thing, ZKMP, that pattern matching, right? But it is not completely based on that. You can do it without that also. I have explained it. Okay, I have explained it already. What you can do is you can go back to the previous one and check it out. Okay. Now see, he is doing a lot of operations which I don't think is necessary. It is just there to make it much more easier. But since you know that it is big O of last lead code was so genuine. Last lead code was so genuine. The bi-weekly or the last lead code weekly contest. So since he's doing this multi-set thing, 23 only people were able to solve all four problems. Mhm. So it is like basically nothing but what he's doing is he's just calculating for the median. Okay. So he has a median thing. So what I'll just prefer you guys to do is like you can go and check out this problem, find median from data stream and get into it so that you know what how to do that multi-set thing. But I don't think you will be needing that because what you can do is since you need to find the median for a specific array, okay, a specific part of the array, and you have the opportunity, okay, you have the opportunity to go for what to say, to go for big O n squared, right? Bi-weekly one. So that is yesterday's one, na? Yeah, yesterday's one was good, man. I was not expecting. I got a 500 something ranking. I was not expecting. I was expecting a 2000 because I thought that I couldn't solve it. So yeah, it would be very bad. But yesterday one got it was good. And you know why it was good? Because there were a lot of people who were giving code forces. Okay, so like let me tell you one thing. Like obviously there are a lot of people who just use this Telegram to code. So yeah, the Telegram coders were divided into two parts. So yeah, it was better yesterday. So if you have the opportunity to go for big O n squared, what you can do is you can find the median directly. Okay, you can use a kind of priority queue. Okay, but you can, or you can use a queue. Okay, you can use a queue rather, or you can use a normal vector also you can use. So using that, what you can do is you can find out all the elements over here. Okay, and put it into a vector. Let's say it is A, B, C. Okay, put it into the vector, and you can sort it out. Okay, you can find the median of it. Okay, what is the complexity to find the median of any number? It is basically nothing but I think you will do it in big O n log n, right? I want to grind code forces TP problem. Can you help me? Yeah, we can do it. Right, so this is a big O n log n thing, right? So what we can do is we can have this thing, this vector, the pattern of a hash map. Okay, we can have it in the pattern of a hash map. That this is what my logic is. Okay, hash map or map. Okay, so where in which we can do is that for every specific corresponding element, we can find out its, we can map it to its position. Okay, we can map it to its position, so that even after sorting, I want to learn writing the tabular DP. You know memo code, I want to learn the tabular DP. Okay. Great, I got it. Yeah, you can do it, man. Like, I think this Shine guy, I'm not sure about this. His name goes by this. Shine, something like that. Okay. This guy is a very good one. Okay. He does a lot of helpful stuff. I have personally subscribed him, and I go and look at his editorials and solutions a lot. Okay. So yeah, that's the thing. He is a good one. You can go and follow him. Okay. You get to understand. He has got some videos on TP. Okay. You can go and follow that. So what you can do is you can find the thing in big O n log n, right? You can do it in big O n log n. Find the median, and that is just to sort it. Okay. Now the fact is that you have sorted it, right? You have sorted it. You know that ABC. You have sorted it, and you have found its median. Now for the next element, whenever we encounter D, so we have to remove A and replace it with D, right? How can we do it? In the hash map. Okay. In the hash map, I know what is the position of this. I mean, at this position, what is the element? Okay. So if I'm maintaining two hash maps, or rather, I'm one hash map only, it works. And I know that this is sorted, right? This thing, now it is sorted. So I can find out A in log n time using binary search, right? I can do it in log n time. Remember one thing, this n log n is going to occur only once. That is at the beginning. You can find out the first x elements and do it. Okay, and done. You don't need to do anything about it anymore. And now that you're done with it, now for every specific time, you're maintaining a hash map and you have to find out that it is a sliding window, right? It is a sliding window. What happens in the sliding window is, let's say if, you were considering this sliding window, the next moment you're going to consider this one. So you're removing the first element and you're adding the last element, right? So you can find out the position of the first element and replace it with the last element, right? Now that you have replaced it with the last element, now there is something that you have to understand. Okay, it is going to make your whole thing, right? It is going to make the whole thing kind of non-sorted, right? Because that D is making the non-sorted thing. You don't know whether the D is in the perfect position or not, right? It may happen that D is the largest element, but it is at the A because A was the smallest element, right? So how would you do that? It is also very simple. Okay, what you can do is over here it comes about the queue thing or priority queue thing. Okay, you can just remove from the priority queue an occurrence of A, and into the priority queue you can add an occurrence of D. Okay, and you're done with it. We go login. Okay, done with it. Now that you're done with it, now you can find the median. Okay, I think this is actually what he is using the multi-set for. Okay, if you look into it, you will get it. So once you're done with all the medians, so you know about his red values that I was explaining, and now that you know about his red values, so it's very easy for you to do the DP thing. You can look at what he's done for the DP thing. I'll show you. Where the heck is the DP thing? Okay, the DP thing is over in the solve, I guess. You know? It's in the solve. So he's doing for partition and I. Okay. So if partition is equal to k, that is I have done with all the partitions, so return 0. Okay. And if I is equal to n, which means that I have reached the end, so return 1 into 10 to the power 15. What do we mean by that? It is basically nothing. It's not 10 to the 15 is not a number. Like it is infinity. Okay. That is what he is trying to tell us. And if dp of partition of I mean till I making that number of partition, it is not equal to -1. That means we haven't gone till that position yet. Okay. I mean, sorry, we have already done that. Okay. That is the memorization thing. So if we have already done that, so return dp of power of I. Otherwise, we have to compute it. Okay. How can we compute it? Minimum of answer, comma, MVS of I plus solve partition plus 1 I plus x. That is, you're going to consider a partition from that specific value of I. Okay. It is I plus x and power plus 1. What is MVS? It is the minimum number of operations to make that specific thing into its median. That is the minimum operations to make all the elements of that equal. That is MVS of I. Okay. This MVS of I, it is very simple. You can do it. Okay. It is not an issue. That is MVS of I is what I was explaining in this portion. And now that you're done with it, so you can get the DP of I. Okay. Is it clear? Like if this part is not clear, this the number of nodes can be calculated as number of elements less than equal to median into median minus sum of elements in subarray less than equal to median. Then that is okay. I get it. It is something of greater thing. Like you don't have to consider that. This is just for to make the calculation much more simpler. You can have that hash map thing that I just explained you, and you get it. Okay. I think from apart from this, it is clear, right? So let's conclude with the video. Let's rate the problems. Okay. Okay, I think I can make a table now. I'm not sure, but can I make a table in Paint? Oh no 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 no. No. Okay, so I don't think I can make a table. So I'll just go for it. I'll just make lines. This is for medium. Hard. Easy. Okay. Easy. Medium. Hard. I think A and B, I'll put them into easy. Okay. A and B were easy. C was a little bit harder than medium, and D was hard. Okay. Or rather, I'll just do one thing. I'll put both of them as hard. because I think they deserve to be at high. Okay, together. Okay, so yeah, that's it. That's it from my side. I don't think. Is there any contest today? Tonight? I mean, let me check. So based on that, I can come live. Okay, so there is a ad coder contest tonight, and there is also a GFG contest, right? I have not been doing GFG for a lot of long time. This ad coder thing is for 7, 8, 9, 10. It is 3 hours. I think it's too much for me. Okay, so the ad coder thing I won't be coming live. This is for sure. But I may come live for the lead code. Not the lead code. I mean, I may come live for the GFG thing. Okay, just a minute. I think I have some. It tells that my present lead code account is having 2101 rating. Just a minute, huh? 2101. Because I have two accounts now. So I don't have the password for the previous one, so I asked this one. Okay, I don't have the password for this, so I use this Griffin code thing. So I think I have surpassed my previous one. Oh no, it was 2118. This is 2101. So yeah, almost. Okay. So I'm almost there for to surpass my previous one. And the most funny thing about it is that this one that I do, this Griffin code, this is just for like I'm not doing much serious coding stuff over here. Okay. So yeah, that's the thing. Yeah, it is 2101. Great, great, great. Okay. So that's it from my side. Thank you guys for joining. Okay.